All right, so now we're on to the second part of this question, lines 4 to 6. So before we execute these lines, I want to draw your attention to this statement that comes before them. So we're actually now casting and actually reassigning NA to AB casted to the static type A. So now keep in mind that the static and dynamic types of NA are different from what they were before. So the static type of NA is going to be A. The dynamic type is going to be B. And I got this because I know that the dynamic type of AB is B from here. Okay, so with that in mind, let's execute this one. So NA.F, that means that at compile time, the compiler is going to go inside the A class and see if there's an F method that takes a nothing. There is. It's going to screenshot this, and then at runtime, it's going to look inside the B class, see if there's another method of the same exact signature. There is, and we can actually override the screenshot at compile time because F is a non-static method. And so actually we're going to be executing this one, which means, whoops, I forgot to delete that from the previous part. So we're going to be printing out B, F, and then XY, which is going to come from the class B. So 3, 4. And so I guess I could just explain a little bit more in detail why we're just assuming that we're taking these variables from the same class that we're in, unless it's something like this. The reason is because these are all implicitly this thought X, this thought Y, right? And so unless you do something like this, where you have a specific, sorry, I shouldn't use this as a conversational word because this overlaps as a keyword in Java. But basically in here, we have a reference to a different object than this, right? We have a reference to X. So in that case, we need to go inside the X's static type class, not dynamic, static type class, and then look at its X and Y variables. Okay, and then we're here now. Okay, so NA.H passing in AB casted to A. So this is kind of similar to what NA is already, right? Because that's how we defined it here. Okay, so first of all, at compile time, it's going to look inside the static type A class for an H method. We know that it exists here. And because it's non-static, we can potentially override it. And we actually do need to because NA has a dynamic type B, so we need to look inside the B class, find the same method header here, and print out B, H of A, and then X is going to be this, right? So here, the A represents the static type. It's not, the type here is not referring to the dynamic type, it's referring to the static type. And so when we do x.x and x.y, we're actually looking inside the A class, the static type A class, which is going to be here. And so we're going to be taking 1 and 2 as x and y respectively. All right, and then the last part for line 4 is this one. So we're going to be calling the H function. And again, we know that the compiler is going to screenshot this one, but because it's non-static, we can override it with this method at runtime. And then it's going to take in this, which is a C instance, right? But actually, we don't even need to cast it to an A because just by passing in a child class of the class A, compiler can automatically cast it for you without you explicitly doing it. So this call is really the same thing as actually explicitly casting it before you pass it into the argument here. The compiler will just do this casting under the hood automatically. And remember that this is upcasting, right? So we're casting a child class to a parent class, which is okay because we're going from a smaller box, fitting it to a larger box. But if you were downcasting from a parent class, bigger class to a smaller child class, that's not going to work because we can't fit a large box into a small box, right? Okay, so with that, we're going to be executing this one, and that's going to be B of HA. And then now this is a pretty fun part. So again, we only care about the static type of X, which is A. We know that here, the dynamic type of X is actually C, right? Because this comes from new C. But again, we only care about the static type, and so it's going to be from the A class, which is going to be 1 and 2. So that is going to be the answer for line 4.